this time, let's take a look at the constant multiple rule or the constant multiple law of limits. So let's consider a function defined for all x over an interval. X may not be equal to a, and assume that L is a real number such that the limit of f of x as x approaches a is L. If this is so, then we say that the limit of c times f of x is equal to c times L, where c is a constant. So if you look at this, the limit of a constant times a function is just equal to the constant times the limit of the function. So let's look at it through some examples. So the limit of 3x as x approaches negative 1. So we assume that 3 is the constant, and we assume that x is the function or f of x. So we will factor out 3 from the limit by the constant multiple rule. Now, we use the basic laws to evaluate this. We get 3 times negative 1, which is the limit of x as x approaches negative 1. We simplify, we get 3 times negative 1 is negative 3, so therefore the limit of 3x as x approaches negative 1 is negative 3. Now the limit of 2x minus 6, this is a difference. You have 2x and you have 6. You subtract 6 from 2x, so we can use the sum or difference law or rule. So we distribute the limits, and then we will use the constant multiple rule by factoring out 2 from 2x. So we will use the basic laws. So we get 2 times 4 minus 6. 2 times 4 is 8 minus 6 is 2. So therefore the limit of 2x as x approaches 2x minus 6 as x approaches 4 is 2. Now, if we have 10 minus 7x as x approaches negative 2, again, this is a difference of two functions. So we get the limit of 10 minus the limit of 7x from the sum or difference rule. Now, if you look at 7x, we can factor out 7. So we get the limit of 10 minus 7 times the limit of x. The limit of 10 as x approaches negative 2 is 10 minus 7 times the limit of x as x approaches negative 2. So we get 10 minus 7 times negative 2, which is 10 plus 14, or 24. So the limit of 10 minus 7x as x approaches negative 2 is 24.